Exercise 5F, determining rules. Today we are learning about finding exponential or logarithmic rules, and in terms of what you need to be able to do, you need to be able to find key point using a graph or a problem, use these points to create simultaneous equations, and then you can solve these equations to determine the rule. So we have done this over and over again with all of these other different functions. Basically, to be able to find the unknown, A, B, or C, you just need a point for each unknown, and then you can create equations and solve it from there. You need to know the basic equations, of course. So for the exponential graph, it looks like this. We've got lots going on here. So both A and K are dilation factors, and B and C are translations. And then, of course, for our log, we've got this rule over here. In this case, A and K are once again our dilation factors, and B and C are our translations. You need to know that exponential graphs, the key feature is an asymptote at y is equal to c, and for logs, the asymptote is at x is equal to b on k. Why we say that is because, as always, you need to make sure you pull out any number that's in front of the x so that you can see the true translation. So make sure anything in front of the x comes out, and that'll show you your asymptote. Example 16. The equation of the graph shown is of the form f of x equals ae to the power of x plus b. Find the values of a and b correct to two decimal places, and then hence find the equation of the function. So we've got a couple of different things that we need to do. First of all, we need to make sure that we find the values of a and b, and it has to be to two decimal places. This indicates that we're going to use our CAS calculator to help us. And then finally, or secondly, hence find the equation of the function. So then we need to substitute a and b back in. Now we have two unknowns, which means I need 2 points, which is exactly what I've got. I've got a point here and I've got a point here. From there, I can create simultaneous equations. So if I just write out my values, so that's 2.440 and 0, 2. This is x and y, and this is x and y. And so I can go ahead and substitute these into my function. Remember, f of x is also y equals. So I can go ahead and sub them in. So if I want to sub in this first point, for example, I will go 0 is equal to a e to the power of negative 2.44 plus b. That's my first equation there. And then for my second equation, I'll sub both in again. So 2 is equal to a e 0 plus b. This is really convenient when I have this because e to the power of 0 is 1, so 2 is equal to a plus b. I now have two equations, and of course we can sort of work through this by hand, but there will be a point where I need to start to use my CAS calculator because of these particular decimals right there. So all we can do from now is that I've got two simultaneous equations. I've got this one, and I can go straight into the CAS calculator and solve it. Especially because it says to two decimal places, that indicates that I can use my calculator to solve it. But we're going to go to calculator. You'll go to menu, algebra, solve system of equations. And we want two equations, and our two unknowns are a and b. So I'll press OK, and then I'll go ahead and type both of these equations in. So the first one was 0 equals a times e. Now the way that you can access your e is at the bottom left, there's the pi symbol with an arrow. If you click on that, it'll come up with a whole bunch of different values such as e and pi and so on that you can select. So that's e to the power of negative 2.44 plus b. That's the first one there. I'll make it little b just to match. And then for my second equation, I had 2 is equal to a plus b. So now that I've got my two equations, I can press enter, and I've got my two answers there. So I can go ahead and just copy that in. So that will be a is equal to 2.19 and b is equal to negative 0.19. So now that I have both of these to two decimal places, I can go ahead and find the equation of the function. So that's going to be 2.19 e to the power of x minus 0.19. Example 17. The equation of the graph shown is of the form y equals a log e x plus b plus capital B. Find the values of a, b, and capital B, and hence find the equation. So once again, I have three unknowns and I need 3 points. Now you can see I've only got 2 points this time, but I do actually have some extra information, which is an asymptote. And it's so convenient because I can substitute that directly into my value. So the whole graph has shifted over by 1 to the left, which means that inside my bracket, the sign needs to be the opposite. That'll be +1. So b, we can already tell, is going to be 1. So that's really nice that that's already there for us. So I can write down the equation that I've got so far, x plus 1 plus b, and now I have two unknowns, and I can use my 2 points, 0, 5, and 2, 0. So I'm going to go ahead and substitute these in, 1 and 2, so that'll be, for equation 1, 5 is equal to a log e 0 plus 1 plus b. Now log e 0 plus 1, which is just 1, log e1 is going to be 0. So in fact, I've just found out that capital B is equal to 5, which is very convenient. And then for 2, I can go ahead and substitute in the values again. That'll be log e x plus 1, and I know that b is equal to 5, so I can put that in. And from there, I can solve for a straight away. So first of all, I'll take the negative 5 over. In fact, I didn't actually sub in what the value of x should be, which would be 2. So I'm just going to put that in. So 2 plus 1 is 3. And now I can divide both sides by log e3. So remembering that log e3 is actually a number. So there's no x's in it, it's an actual number there. So that's it, that's a. So now that I have my a and b, I can go ahead and substitute that into the final equation. So the equation is y is equal to a. So that'll be negative 5 on log e3, log e x plus b plus capital B. And there's your final equation. And that's the end of exercise 5F.